When two coins are tossed, A is the event of getting two heads. When a die is rolled, B is the event of getting a 5 or a 6. Show that A and B are independent events. So if you look at the formula book, it says for independent events, P, A and B equals PA times PB. So basically, we can find PA, we can find PB. If we can then find PA and B in a different way, and then we can prove that it's the same as the product of these two, then we have shown that the events are independent. It's not the only way to show it, but it's definitely the easiest case for this particular thing. So it's a bit of a pain actually. One of those questions, it's so simple that it's quite frustrating to do. But you need to find a way to systematically represent all possible outcomes. So a tree diagram would be a bit of a pain just because you probably have 6 things on here, or you might have to pre-draw a run and work out probabilities. So what we're going to do is a 2D grid, and it's probably the only time you'll be asked to do this in the IB. So let's draw a 2D grid. So this can be the coins. We're drawing 2 coins. So we can list all possible outcomes of the 2 coins on this, and then we've got the die on here. So then we need to list everything that can happen. Well, the die is easy enough. That could be 1, 2, 3, 4, 5 or 6. So 1, 2, 3, 4, 5 or 6. The coins, well, that's a bit different. Normally, certainly IGCSE, it'd be one of the first things you do with probability. You show them different ways of showing that the probability of getting 2 heads, or showing what it is. So, but seeing as we're a bit further on, I'm going to say there's 4 possible outcomes. There's heads, 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 tails, tails, heads, tails, tails. So write that down. So heads on the first coin, heads on the second coin, heads on the first coin, tails on the second coin, tails on the first coin, heads on the second coin, and tails on both. There are only 4 things that can happen when you toss the 2 coins. So if we then do our little 2D grid, basically there's a point for everything, a little point, and then the total number of points is the total number of possible outcomes. So all I'm doing, I'm just joining the intersections on the grid. And it's a bit of a pain, and I would be very surprised if you have to do this. But it is kind of where probability starts, so it's not the worst thing to see. So this now represents the possibility space of all possible outcomes when we toss 2 coins and when we roll a die. So there are 1, 2, 3, 4 this way, 6 that way. There's 24 possible outcomes, right? So remember the golden probability formula. The probability of something happening is the number of favourable outcomes, e.g. the number of outcomes that involve that thing happening, over the total number of outcomes, which we've just said is 24. So if we find P of A and B, which we're interested in, I've just said there's 24 possible things that can happen. So how many of those involve getting 2 heads and getting a total of 5 or 6 on the dice, or getting a 5 or 6, not total? So, well, that's these 2, so that's a 6 and 2 heads, and that's a 5 and 2 heads. So there's 2 of those, so it's 2 over 24, which may be useful to make it 1 over 12. So then we can find out PA and PB separately, so you could potentially use the same thing. I mean, PB's pretty simple, but let's just say, so probability of A, which was, A is the 2 heads, so there's 4 things that can happen on the coins, one of them is 2 heads, so it must be 1 out of 4. PB is getting a 5 or a 6 on the dice, well that's going to be 2 out of 6, or 1 over 3, so I'll put 1 over 3. So then we need to show that PA times PB, we need to see what that is, and hopefully we're going to show that it's the same as this. So it equals 1/4 times 1/3, which is indeed 1 over 12. So that's showing us P, A and B, which equaled 1 over 12, does equal PA times PB. So A and B are independent events. Events.